Well, hello students and seekers of general truth. We continue our study of area with a formal definition of what's known as the definite integral. Okay, so let's get right to it. The definite integral is the area between a function and the x-axis for a given interval. This function here, we assume it's f of x, to clarify, okay? And the x-axis for a given interval. Any area above the x-axis, we deem it positive, and any area below the x-axis results in a negative value. And so let's do a quick example here. So this sort of elongated s here is the definite integral symbol. Okay, so we indicate it with, that means to calculate the definite integral. This is the left side of the interval. This number here is the right side, or the upper bound. Okay. This part in here, x minus 1, that tells us the function. And then the dx here indicates the variable. So sometimes oftentimes, you may see multiple letters here. You may see like ax squared plus bx plus c, for example. That's a bunch of letters. But we need to figure out which one of those is the variable of the function and which one of those are placeholders for constants. Okay, so what this is saying is I'm looking at number 5 here. This is saying take the graph of x minus 1. Okay, so x minus 1 looks something like this. Now it goes through 0, -1, and 1, 0. And compute the area between x equals 2 and x equals 5. Okay, so compute the area between x equals 2. And let me extend this out here just a little bit further. Okay. Between x equals 2 and x equals 5. Okay, and we want to calculate the area between the function and the x-axis. So we're trying to compute this particular area. Okay? And for the first example, the area is fairly simple because it is a nice geometric shape. There's a bunch of different ways that you could use to calculate this area. You could slice this up into a rectangle and a triangle and a number of other things. But first, let's calculate these lengths. So let's look at actually the picture here, and this is actually a nice trapezoid, right? Where this is a base. The two red lines here are the bases, and this green distance here is the height. Remember, the height is perpendicular to the two bases. So the area here of a trapezoid would be equal to 1/2. Remember the formula for a trapezoid? 1/2 times the height multiplied by the two bases added up. So in this case, we know that the height is equal to 3. Right? So the distance between 2 and 5 is 3. This first length right here, this first red line segment right here, we can calculate by plugging in 2 into the function. So when we plug in 2 here, we get a value of 1. So this first base right here is 1. And the second base, we plug 5 into the function, and we get this length must be equal to 4. Okay. So now we can compute the area, and let's just practice writing the notation. So this is the definite integral between 2 and 5 of the function x minus 1, using the variable as x, is equal to, because it's a trapezoid, 1/2 the height times the first base plus the second base. Okay. So that's 1/2 times 6. No, I messed this up. Let me change this. The second base wasn't 5. The second base was actually 4. So this is 1/2 times 3 times 5, or 15 over 2, or we can also say this is 7.5. Okay? So this is the notation. This is just the way, I'm sure you can, if I just draw this picture, everybody can calculate the area, but this is just a way to express the notation. Let's move on to number 6, a little something more complicated. We want to calculate the area underneath the curve between 0 and 5 of this function. Now this function requires a little bit of work for us to figure it out, but we can say that this is like y equals root 25 minus x squared. If you squared both sides, you get y squared equals 25 minus x squared, and then add x squared to both sides, and we get x squared plus y squared equals 25. So this is effectively a graph of a circle, but we're only looking at the top half of the circle. So you could, of course, plug this into your calculator, into your graphing calculator, and see exactly what it is. Right? But knowing a little bit about coordinate geometry, we can figure that out. So this is 5 up here, negative 5 over here, and positive 5 over here. And we're trying to, and this is the graph between, that is the graph of root 25 minus x squared. And we want to find the area between x equals 0 and x equals 5. So that's this area right here, which is a quarter of a circle. Which is equal to 1/4 pi r squared. And in this case, well, pi is always a constant, and the radius happens to be 5. So this ends up leaving us with 25 pi over 4. All right, students. So that was a nice. Hopefully that was a nice and brief introduction into what a definite integral is. The main takeaways here are how do we interpret the notation, and secondly, how do we visualize or draw a picture of that graph. As always, keep working hard. Ask for clarifications whenever you need it. Thank you for watching, and have a wonderful day.